Hi, I'm Thomas Krijnen. Started IFC OpenShell now 11 years ago. There has always been one central question on how do we get the data on our built environment out of these models and into something else, into an algorithm, into another model.
Hey friends, welcome back to BIMvoice. Today I have the pleasure to talk to Thomas Krijnen. Now you will need to pronounce that name correctly after I finish here. We are going to talk about some interesting projects that Thomas is involved in. With no further ado, Thomas, please tell us a few words about yourself, what you are doing today, and then we can jump into the very important project for the open source community for AAC, IFC OpenShell.
Thanks for having me on this occasion. Yeah, and the pronunciation was perfect after practicing once. Hi, I'm Thomas Krijnen. I don't know, maybe just a little bit of history. I think I started IFC OpenShell now 11 years ago. And yeah, maybe we get to the why and the how, but it has been kind of a thread through my life now, I guess. In my first professional experience as just an employee of a company, and later my PhD that I did in Eindhoven University in the Netherlands. And then now my professional life as an open source or open standards consultant in our built environment industry. There has always been one central question on how do we get the data on our built environment out of these models and into something else, into an algorithm, into another model, into our heads, into a big database of our entire built environment. I have that same question on many levels. I think for sustainability, we really need to document better what we have built, what we can reuse from it later, what buildings are empty, how different are they from what a potential new client needs, these kind of questions. But also for collaboration, how can I map your data model onto my different data model? In the end, we're talking about the same physical things, describe it different. And I really hope that with tools, we can get more collaboration and a better building.
That's at the core, actually. I see also that as the main issue in our industry. Like, we still need to tweak up and improve a lot the communication, the collaboration part. It's still not a business as usual yet.
No, and I think to a large degree, these things are solvable. It's not that different in terms of how we express things. I mean, sometimes it really breaks down at the most trivial things, like you call this property A, I call this property B. Sometimes it's more about how you model the geometries, break it up into separate elements or layers. But all these things, they can be transformed. And that's really what I hoped to accomplish with IFC OpenShell. That's also why geometry has been such a core part of it. That's actually only how it started. I only had the idea basically to take IFC and map it to the Open Cascade and the geometry library we mostly use. To that API, and from there on it grew to a more reliable parser and all sorts of APIs. Yeah, now that Dion is involved also end user applications and many more things.
But tell me something. Are you educated as an architect or a programmer, or what is your background from university?
I did start as an architect. I think most of the people we work together with in our industry do actually come from really just the traditional architectural engineering background. But quite early on, I think I just basically realized that my life would be much easier if I focus on some sort of software component. It wasn't obvious to me at first. At first, I thought I would become some sort of a, generative design expert or something, write code, but really aimed at still producing buildings. But yeah, that wasn't something. That's a hard life, That's really hard work and you have to be really exceptionally good. Yeah, and all these things basically. My first professional experiences, my academic experiences, everybody was just shouting at me, BIM, 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 IFC, Thomas, do it. And, I'm still reluctant. It's boring, I know, etc. Yeah, in the end, it's also not that boring. There is like you say, interoperability and data is really at the heart of the problems in our industry. And I do hope that it is what I can provide is really a meaningful contribution.
Well, it is. because we don't have many, and now we get more and more tools in our stack, like BlenderBIM on top of this, right? Which has at the core IFC OpenShell, like IFC.js, and definitely many other tools that I don't even know about. And everything is based, most of them at least, are based on this, right? Are using to some degree IFC OpenShell. But not everyone watching or listening to this is an expert. Let's start with trying to explain in very simple words what exactly is IFC OpenShell and what it does.
Okay, yeah, I think for that it's really important to understand what IFC is. And I think the answer you get to that question is really different depending on whom you talk to.
Mm-hmm.
And I think in its simplest form, IFC is just a set of ideas and classes and data concepts about our built environment in one comprehensive standard schema. So some people would focus on the schema. They don't look so much at the other things. Other people would emphasize more the use cases or what they call concepts in IFC, that you have these building blocks of data that facilitate certain exchanges. But I think most of the software people would mostly recognize the schema, the set of classes that IFC provides. You have a wall, a column, a beam, but also, let's say, geometric entities, a circle, a line, a polyline, and then extrusions, but also other multidisciplinary facets like tasks or cost-related concepts. And then what IFC OpenShell is, basically, in its simplest form, just a tool to read and write that kind of data. And evaluating also the geometrical complexities that you can express with IFC. Like where it's really different from most other, let's say, geometric mesh formats is that the geometry in IFC is really procedural. So you define a polyline and then you create a profile out of that and then you extrude that and then you cut out openings into that. Yeah, that requires some work to make sure that you can actually visualize that kind of geometry. At the heart, those are the two components, I would say, reading and writing the data, visualizing or analyzing these kind of procedural geometries. But like you said also, now with BlenderBIM, and it probably grew to a lot of other things also. There is now, in IFC OpenShell, there is modules to handle BCF, for example, the BIM collaboration format, IDS, a very new information delivery specification standard to really express what kind of supplementary data you need, particular kind of elements. So the beauty also of running an open source project. I've always been focused, let's say, on the foundation, but around that, a lot of beautiful stuff grows kind of organically.
That's very nice, very fulfilling to see, actually. Yeah. To what degree would you say that IFC OpenShell reads and writes IFC schema? Is it a copy 100%? Like everything that IFC schema describes can be done through IFC OpenShell, or there are any limitations?
For that question, it's also a matter of what level you look at. So let's say the parser is generated from the schema. So on that level, you have 100% coverage for reading and writing. But then on top of that, there is the evaluation of the geometry definition. And there, for the typical 2x3 geometries, we are pretty complete. For IFC4, we're already a bit lagging behind in terms of the more advanced geometries that we don't see that often. And then for 4.3, the new IFC standard that also supports infrastructure, we haven't even really started yet supporting those kind of geometries. So there you already see that if you're looking at that level, no application can cover 100% there, because IFC is really quite complex and huge. And it's also combinatorial, you can have this kind of sweep combined with that kind of profile that maybe gives you difficulties in certain situations. There are no applications is 100% covering the specification. But up until IFC4, we're quite close. And then on top of that, you have the other applications like BlenderBIM that also rely on the geometry interpretation and the parser, but also add functionality to create data. So there you will have an additional level of potential blind spots of the specification.
It is only you working on this project, or do you get any other help I mean only IFC OpenShell. I don't talk about applications that are built on top of it.
Well, I've definitely, for the lifetime of the project, I'm the one who is most involved in the core part. But I think I would also want to highlight that incidental contributions from others can really be quite meaningful and significant. So GitHub has these nice contributor graphs, right? That over the lifetime of the project, you can see who committed when. I'm this long stretched marathon runner maybe, but there are incidental contributors, maybe somebody who is involved for a month or maybe even just one commit, but it can sometimes be really, really significant. So yeah, again, if you look at it over this entire project lifetime, it's mostly me working on these core parts, but there have been 130 other contributors, including then also the higher level stuff, but also definitely on the core parts that have tremendously helped.
That's very good. That's very nice to hear. Did you mention any increase in the level of contribution lately? Did you see any difference during this long period of time you've been working on the project?
Hard to say. I have been meaning to try and figure that out. I don't have the feeling that it is dramatically increasing, at least. I think overall it's quite stable. Now with BlenderBIM, we have a couple contributors that are really significantly committing effort. But it's still mostly on the core parts, mostly dominated by these kind of incidental things. And it's really hard to figure out trends. I think for a large, what you can also look at is not only the contributions, but also the issues, the bug reports.
Yeah.
And there I see a bit of a decreasing trend. And I think for a large part that's maturity of IFC OpenShell. Geometry is always immensely hard to get right. If you look at these kind of professional companies that work on geometric products, you really have hundreds and thousands of test cases. Insane numbers, because you always make assumptions. That's the thing with geometry. It's very hard to really prove that it's generally works. So there's a lot of assumptions, and assumptions will always be broken, and then you create new test cases. But IFC geometry also isn't typically that. We don't create very complex buildings, apparently, but also it's also the exporting tool. At some point also figuring out kind of the level at which it makes sense to export complex geometry, and at which point it's maybe better to fall back to simpler explicit geometries. So if you add all these layers together, the maturity of IFC OpenShell, exporters getting better at exporting reliable data, also OpenCascade, the geometry library, making massive steps at improving their reliability, means that overall I really see a decreasing trend in at least the amount of issues and bugs.
That's good. That's promising. You talked about the different levels of how updated IFC OpenShell is, and you said that IFC 4.3 it's still not in the works. Is there anything else that you can do more than just provide a full capabilities of reading and writing IFC? Is there anything more than a library could do than just to provide these capabilities? Do you have any other ideas, maybe a better question to ask, that you would like to implement in this project, or the pinnacle of this project is just to replicate as easily as possible reading and writing everything from IFC schema, doing it without unexpected results and so on, without bugs?
That's an interesting question. I would also answer it in a bit of a mysterious way, maybe, that, in open source software, you don't really look, at least I tend not to only look at a single software library. You look at the whole ecosystem. And then maybe you can indeed say that, at some point the basics are covered, it's mature enough. Sure, there will be bug fixes, there will be maintenance, but overall we're nearing a point that not a lot of effort has to be invested. And then you will typically see, I think, is that you would move your attention to neighboring projects. And also there I'm involved in quite a couple. There is, for example, what we call the voxelization toolkit, which looks at this really low-level geometric representation of mass, basically. Voxels are really nice for volumetric data, and then build all sorts of analysis and algorithms on top of that. So a couple of things that are really nice to perform on the voxelized representations are, for example, separating exterior from interior. Because you have all these little connected cubes, you get a really nice enclosure of your building model, and you can easily negate that, for example, and then you're looking at the exterior and the interior, these kind of analysis, but also wayfinding in 3D, taking into account obstacles. Really, these kind of questions at the intersection of topology and geometry are really nicely answered there. We also have a processing pipeline that we call, well, very uninspiringly IFC pipeline. That, well, it's a very lightweight web interface basically around IFC OpenShell. So it accepts a file, runs these kind of processing or analysis tasks, spits out the visualization or easy to adapt, spits out other analysis results. We actually deployed it in a government project that for code compliance checking. It also integrated the voxels, and you could do this kind of building permit checks.
Is this also an open source project?
Yeah, it's open source. We don't have the time to really document it or, to the extent that you expect from a community-driven project. So it's basically just that we dump the source there, and there is a couple of adventurous souls that dive into it, but it's not this kind of dynamics yet, unfortunately.
Yeah.
But still, going back to your question, there is still some big tasks that I would like to
address,
fulfill, on IFC OpenShell itself, and that is, on the one hand, the ability to select other geometry libraries. So now OpenCascade is really hard-coded into the geometric analysis module of IFC OpenShell, but I want to provide a higher level of abstraction and then also create some rough prototypes, other geometric libraries, other methodologies also. OpenCascade is BREP, boundary representation, which is really complete and really perfect for complex shapes. We tend to see in IFC, though, that there is a lot of more actually mesh-based exchanges. And then OpenCascade also has a lot of overhead, because if you have a detailed mesh, OpenCascade for every triangle will fit a plane through it, and it will create 2D edges onto that plane. So there is a lot of overhead. And
sorry for interrupting, but I am fighting exactly with that issue, with that challenge with the delivery. I will actually publish, I think this week, the first part of a video I made together with Dion. He was kindly guided me through, and he looked at a model and an IFC file from me, and we found that actually that is a big issue. Like some very small elements have a huge impact on the entire model just because they are BREPs and everything else is not.
Exactly. You can have I don't know, a gigabyte IFC file where 99% is, I'm exaggerating a little bit maybe, where a really significant percentage is just explicit faces of a single element with maybe multiple instances, but still a single element geometry. And then maybe you can combine these kind of things, for the advanced curved surfaces, you rely on OpenCascade. For the detailed meshes, you rely on Seagull, or even something simpler than that. And then you can kind of combine that into a hybrid kernel to really get the best of both worlds kind of geometry processing. I'm actually quite far with that. The University of Delft was kind enough to hire me to work on that, because they rely a lot on Seagull for their geospatial processing. So I'm quite far, but the code bases have diverged a bit. So now I need to really sit together and merge everything back into a new release of IFC OpenShell. And then maybe also some other programming languages. Maybe C#, maybe JavaScript, maybe WebAssembly. Get some more users the ability to use this tool. Because it's quite cheap actually these days to generate other languages out of a low-level language, C or C++. So yeah, why not spend that effort and really get IFC OpenShell into the hands of more people?
Yeah, although I'm a fan myself of Python, I must agree with that. And if I'm thinking correctly, I might be wrong, but this is just a thought that crossed my mind right now. In the construction industry, many developers who are working C sharp,
C sharp,
developing
yes.
tools, right, for different products. So then maybe it's going to reach new base of users who could become maybe contributors, right? That's not
Exactly,
bad
exactly.
idea, yes.
There is a large group of tools that are typically Windows only, and in those cases, .NET and C Sharp from Microsoft really provide a
Yeah,
great ecosystem to enable scripting in these tools. So
yeah.
yeah, exactly. C Sharp is very heavily used in our sector, and it would make a lot of sense.
And then JavaScript. Do not forget about JavaScript as well, because now full host of IFC JS developers is taking shape, because through these courses, crash courses that these guys, Antonio and everyone else are running, there are quite a lot of people involved in the project, and they are developing a lot of tools. So it would be very nice that they could also maybe contribute to the core, to the root of the tool that actually is supporting this, right? So that would be
Definitely,
also
yeah.
smart.
On the other hand, we also need to figure out how to prioritize things. And if we already see that IFCJS is getting this kind of adoption, then yeah, I don't know. Yes, we can help them. We also need to ask ourselves, are they really... There's different methodologies to develop software. And what you typically see in web-based environments is that they're not so keen, let's say, complexity, in the sense that they're not so happy to take this 1980s Open Cascade 100 megabyte dependency just to facilitate this one use case where you have, I don't know, Boolean operations in a NURBS surface or something. IFC OpenShell is really started from a sense of, yes, let's go for 100% coverage at the expense of higher complexity. And I think IFCJS, because of also how web people think, maybe is more from the perspective of, let's focus on this 80%, which in the case of IFC is maybe 99%, focus on simplicity. And simplicity is good. I mean, simplicity in the good sense, in the sense that complexity is expensive in terms of developer effort, in terms of getting this 30 megabyte WebAssembly binary every time to the browser. Maybe we'll see these worlds converge also, maybe my effort, what I was talking about, having different geometry libraries also enables WebAssembly users to pick a more lightweight kernel, compile that to JavaScript or WebAssembly and interface with IFCJS. Maybe we see that happen, or maybe we see everybody happy in the complex C++ world and the more lean JavaScript world, and not a lot of need for mixing these two worlds. It also depends a bit on what people ask. I'm like 100% consultancy driven now. Yeah, in that sense, I also have to prioritize what my clients want and need.
Of course, it makes sense.
Yeah, we'll see what happens there also.
Yeah, that makes perfectly sense. Well, Thomas, I feel that we can talk for days like this, but let's wrap this up. I want to end this with asking you, how can somebody reach out to you? I know you are very busy, but I don't know if they have a proposal, or maybe if they need consultants from you. How should somebody reach out to you?
You mean practically?
Yeah,
well,
practically.
Search for my name and send me an email. As an open source consultant, I don't do acquisition. I don't have a sales team. If you have a problem, I will not contact you. You have to contact me. And the beauty is also, quite typically, because of this whole ecosystem of tools that has been developed now, in a couple of hours, typically I can provide a really helpful solution for a problem. Sometimes it's a little bit data massaging. Sometimes it's a geometric analysis that, a lot of people are looking at the same things, They want to extract reliably areas of coverings in a space, or, these kind of things. Or they want to realign certain elements that are easier for processing. All these things, we have now really reliable tools to get started with that. And then it's typically just providing some configuration an integration into an existing code base.
That
That
sounds-
really feels nice. I also don't like long projects and doing a lot of boilerplate work. Solutions can really be quick and
and give results. Provide
yeah.
results. Yeah, cool. Thank you very much, Thomas. I learned a lot from this, and I really hope we can have other chats as well.